From San Jose, John Grump and the Silicon Valley Report.
Welcome. We are still learning the extent to which technology can help us. Sometimes we find a new tool can carry us far down roads we hardly dreamed we could travel. Sometimes a tool just helps people be all that they can be. This week, we'll offer a glimpse of what it takes to make a new computer chip a success. And we'll show you how computers are extending our abilities in two ways: to fly faster than ever and to overcome a person's loss of sight. First, though, a look at this week's stories making headlines. Topping the news, it seems the savior of the United States computer chip industry will be the industry itself. This week, the final report of a 3-year study on the declining world market share of U.S. chip makers was released. The National Advisory Committee on Semiconductors is a high-level panel which was appointed by President Reagan. The panel's final report says the government's role may be little more than encouragement, setting standards, and buying first-generation products to stimulate chip growth. Some industry executives had hoped for a greater government role, helping U.S. computer chip firms regain market share. In 3 of the last 5 years, Japan's companies have outstripped U.S. suppliers in the world marketplace. Well, this has been a full week of new deals for Sharp Electronics. The Japanese consumer electronics firm has signed a series of agreements with U.S. high-tech firms. Pending is a reported deal for Sharp to make consumer products for Apple Computer. Of the 2 signed agreements, one involves linking Sharp's Palm-top Wizard computers to Oracle's database. A second deal sets up Sharp as a manufacturer of Intel's flash memory cards. Analysts say flash memory, faster at erasing and storing information, could be a $500 million market within 3 years.
Intel wants to make sure that it has plenty of fab capacity in place. In addition to that, I believe that Intel is responding to some recent competitive pressures from AMD with respect to pricing. In other words, now they need to make sure that their product not only has the high quality that's expected to have, but also is inexpensive and it can compete in the marketplace.
Sharp also offers its flash memory research capability, as well as a global name in making and selling consumer electronics. To date, only a handful of companies have been able to license any of Apple Computer's technology. Now, a stronger relationship between Apple and Radius is bringing less expensive multi-processor computing to the desktop. A licensing agreement permits Radius to use the networking capabilities of Apple's System 7 and AppleShare in its accelerator cards. The cards not only speed up image rendering by breaking work into smaller parts, but also allow different programs to run simultaneously.
We can actually do real multi-processing, multitasking on a Macintosh, which hasn't been done before. It hasn't been done on a PC either. So now, CPU-intensive applications like photo processing, rendering, things like that, can run in background while you're still doing work on your Mac.
Radius says a Macintosh computer with 3 of the $1,500 Rocket cards can do the work of a more costly, high-powered workstation. In the courts, Apple Computer now claims it was damaged to the tune of nearly $4.5 billion by Microsoft Windows software. Apple's suing over the alleged copying of the look and feel of the Macintosh computer user interface. According to Microsoft, Apple based its damages on lost Apple business and in software sold under the Microsoft Windows banner. Analysts say the $4 billion figure is unprecedented in copyright law and would likely not be awarded. Apple and Microsoft should be in court this summer. Last week, we featured a story on some of the services the U.S. telecommunications structure allows and services it does not allow. This week, we have word of a new handheld device that allows a person with impaired hearing to communicate over a touch-tone phone. The unit is called the Teletalker, a battery-powered receiver which hooks up to a phone with a simple suction pickup. Teletalker converts touch-tone beeps to a text and numbers on its liquid crystal display screen. It works on a simple code. For instance, the letter A is 2, 1 for the first letter on the number 2 key. You can also set up pre-programmed macro messages for easy communication among friends. The Teletalker is still under development, and we'll let you know when it's available. Also in communications, 5 cellular phone companies are joining forces. Ameritech, Bell Atlantic, Nynex, GTE, and Contel will offer universal roaming throughout 130 markets nationwide. For consumers, the network will mean one cellular phone number will work throughout the system. Details of the deal and a name have yet to be worked out. When we come back, we'll look at this week's feature stories. Many technology companies expect the next wave of computing will be powered by reduced instruction set chips, or RISC chips. Now, these chips aim to provide greater speed, yet at a smaller size and a lower cost. A British company called ARM, which designs RISC chips, has linked with an American chip maker, VLSI Technology, and Apple Computer. The three firms share a common goal of making the ARM RISC chip an industry standard.
Apple Computer, known for personal computers, recently joined with IBM to develop next-generation high-powered machines. At the same time, though, Apple is headed the other direction. It is banking on the capabilities of this computer on a chip to provide the brains for a new line of products.
The ARM, although it's also a RISC processor, is really at the other end of the spectrum. It's really for products where low power, small size, low cost, high volume, are the issues. Our strategy for the 90s is to diversify into a broader product line, and the ARM is going to play a very important role in that strategy.
Since the mid-'80s, ARM chips have been the brains of England's Acorn computers. The microprocessor's designers weren't looking for maximum performance, but they did want their chip to be simple and compact. Those factors attracted Apple and chip maker VLSI.
The embedded control environments today just need to move a lot of data quickly.
John Haller says the ARM RISC chips have a wide range of uses in relatively complex consumer products.
Which could be a chess game, or it could be robotics or amusement, toys, full motion simulators. You may have seen some of these where you actually take a ride in a full motion simulator and you think you're in a race car or in a roller coaster.
You find embedded controllers managing auto engine performance, smartening medical instruments, and automating offices. We're really just beginning to see what they can do.
TV games type products again are very appropriate to ARM. Communications products where the computer is coming together with mobile equipment and radios. So we see a whole new range of products that can get into people's hands at a low price.
The thing that really excited us about the ARM was that it had such a small die size, and it was designed as a macro cell that could be put onto a chip, that we could design circuits in the future that had a very small percentage of the area devoted to processing, and essentially create an entire system on a chip.
Where Apple Computer started in a garage, ARM is still in its converted barn. 24 workers designed the latest microprocessor, all 367,000 transistors, in about 9 months. Given shortening product cycles, ARM expects even shorter development times for future chips.
One of the things that we took in mind when we designed this chip is a modular design approach. So we have what we call macro cells, which if you like, are a bit like Lego building blocks. So we have a CPU macro cell, we have video controller macro cells, we have memory controller macro cells, and one of the things we expect is that we will be turning derivatives of these products within 2 or 3 months.
VLSI is now turning the design to silicon and selling a family of ARM chips. Wrapped around the microprocessor core are a variety of specialized functions.
Combined with 4K of memory, content addressable RAM, and a memory management unit, co-processor interface, now available at 35 megahertz.
The ARM 600 has less than 1/3 of its area filled with that core brain power. Long-term, all three companies hope the ARM design becomes a standard.
As processors evolve, it becomes more and more expensive to fund their evolution. They necessarily become more complex. Even something as simple as the ARM will become more complex than it is today, even though it'll probably always be an order of magnitude less complex than the other RISC processors.
It's very easy for the company to grow and for the bureaucracy to grow and for the design cycles to go up. And it is inevitable that our chips will get more complex. We have simple chips, but we have to follow a certain trend, and the chips are bound to get more complex. And the challenge is to keep that complexity manageable.
Just last month, ARM added another licensing agreement with GEC Plessey Semiconductors, which specializes in a variety of computing devices. Having that second source for ARM chips is another step along the path to a standard.